Thank you for joining us, everyone, today. We're very excited about today's discussion. Today, we hope you'll gain a greater understanding of AI, artificial intelligence concepts, including basics of ethical use in medicine. It's a big topic for us, is the ethical use of AI. We want to help you raise your awareness of the potential benefits and the limitations of AI in clinical practice, including the ethical considerations and safety concerns. And we want to assess the knowledge of current and future applications of AI in healthcare, including in imaging, diagnosis, treatment planning, and precision medicine. Next slide, please. No? Okay. Okay, so Harlan, would you? Okay, so I'm so excited to introduce my friend and colleague, Harlan Krumholz. Dr. Krumholz is a cardiologist and scientist at Yale University and Yale New Haven Hospital. He's the Harold H. Himes Jr. Professor of Medicine. Received his BS in biology from Yale, his MD from Harvard, my alma mater, and his Master's of Public Health and Management from Harvard School of Public Health. He's a leading expert in the science of really implementation in all the ways we improve quality and efficiency of healthcare, try to eliminate disparities and promote equity. To that end, his recent efforts are focused on harnessing the digital transformation in healthcare, exactly what we're going to be talking about today, to accelerate knowledge generation and facilitate the delivery of care aligned with each patient's personal needs and preferences. So he's the absolute perfect person to deliver this talk. He is director of the Yale New Haven Hospital Center for Outcomes Research and Evaluation, CORE, an organization dedicated to improving health and healthcare throughout research, tools, practices that produce discovery, heighten accountability, and promote better healthcare and clinical care. He's been honored by membership in National Academy of Medicine, the Association of American Physicians, and ASCI. He's been named Distinguished Scientist of the American Heart Association and received their award for meritorious achievement. He served as a member of the advisory committee to the director of the National Institutes of Health. Maybe most importantly, Dr. Krumholz is one of the touchstones for us in medicine. He keeps us honest. He pushes the boundaries. He asks the tough questions. I can absolutely think of no one better to deliver this talk. Dr. Krumholz, thank you so much for joining us today. You may take it away.
Thanks so much, Carol. I'm so honored to be part of this. Actually, I told Carol, lower expectations because I want to exceed expectations. But now she's given me this a remarkable introduction that I'm so grateful for and appreciative to be part of this. So my charge today was to talk about AI for the clinician, promise, pitfalls, and potential. So let me just get my slides up and it can go off. So let me first start with just a slide with disclosures and go on to both say that I'm also representing my group. I'm from Yale University, but also I'm a director of the Center for Outcomes Research and Evaluation. And my perspectives, my work, whatever I've been able to contribute has been a part of this team, but also a part of so many others that I've been able to collaborate with, including Carol across the country, and very grateful for all of that. So this is really an opportunity to, I think, talk a bit about how all of that fits together, but I wanted to say that that really represents a team effort. So I'd like to set some expectations for this talk. I'm so thrilled to be on the Bridge to AI. I recognize the deep amount of talent associated with this program, the people who are on this call who are spanning a whole range of different areas of expertise. So this is really a conceptual talk, not a technical talk. And like I said, I expect that people listening may be from clinical medicine or engineering or computer science, bioethics, clinical researchers, even experts in legal and policy, as well as patient advocates and patients themselves and more. So, you know, the idea here is to just share some ideas. The organizers asked that I focused on AI for the clinician, but I hope to present some ideas that may resonate with anyone who's hopeful about the role of AI in medicine. And we should also do a talk sometime in the future about what patients need to know, because really we're talking about users of the products that are developed out of this, and that'll be clinicians, but I hope in partnership it will be with patients also. My own journey toward AI in medicine began about a decade ago on a sabbatical year, where I tried to take a good long look at the landscape and say, where do I need to focus for the future? Where should our teams be focusing in the future in order to be able to make the biggest impact? I'm an outcomes researcher. And so what that means is that my science is in a quest to make tangible improvements in health and healthcare. I wouldn't say that we declare any victory until the science can be shown to really improve people's lives and the society that we live in. Outcomes research science seeks to find where addressing gaps in knowledge, gaps in tools, gaps in performance can bring meaningful change in health and healthcare. And in health, I think that really means how long and how well people live, how well they feel and function, how well their preferences and goals align with their care and with their outcomes. Not about how their lab tests change or any of the surrogate outcomes or markers, which may be important to help us understanding mechanisms or maybe intermediate targets, but actually how have their lives been improved. And then in healthcare, it's about the effectiveness, efficiency, equity, patient-centeredness, timeliness, and safety of their care. These were things that were put out by the IOM as they talked about what the properties of a high-functioning healthcare system should be. And this is what are the targets. So I was drawn to AI and data science and informatics because I saw them as transformative tools with the potential to improve outcomes. And I say AI, and then I add in data science, and then the informatics piece, because the data movement, how it feeds in, how we use it, how it's applied, all of these things fit together. So it really is that simple. And I began the slow turn of my research team towards AI and data science and informatics because I simply saw it as immense raw capability to create a better future in medicine and public health, a possibility of better health. And I will say that we've been very much in the early days. The manifestations and effect of that potential, I believe, has yet to be realized. And if you look at the country at large, even before the pandemic, we're not showing transformative inflection points in improving health, improving equity, improving efficiency within our healthcare yet. So we're really looking to this as a central tool that may be able to help us get there. So what is it that clinicians need to know about AI? Well, I think one of the things they need to know, and one of my central theses in the last decade has been that medicine is or will increasingly become an information science. I mean, and this is just, again, a conceptual frame shift from, the kind of education and socialization that occurs to clinicians. By the way, when I mention clinicians, of course, I'm talking about the whole spectrum of the team: physicians, nurses, pharmacists, physician assistants, and I'm not even going to mention everyone in that entire spectrum, but it's meant to be an inclusive term because this isn't just a physician-centric talk, or it's not meant to be just for physicians, but for all the health professions. In our socialization and in our initial education, it was very mechanistic. It's trying to draw inferences and make projections based on our understanding about how the body works and how disease works and what we can do to help people to achieve better health. But it turns out over time that those kind of basic mechanistic understandings, although important, informative, especially for developing new approaches, doesn't always capture what's going to happen with individuals. And we weren't adequately harvesting the kind of information that was available to us based on everyday practice. And increasingly, medicine is going to be able to leverage this for better and greater understanding. So around that time, 2014, I'd written this piece in Health Affairs called Big Data and New Knowledge in Medicine: The Thinking, Training, and Tools Needed for a Learning Healthcare System. And I was trying to bring together this notion of the increasing capability that was within our grasp. Now, this is almost a decade ago, and I wish we'd made even more progress since then. But the idea that we could bring together this capability to bear on real-time learning in what was being called and continues to be called a learning healthcare system. And I wrote that big data in medicine, massive quantities of healthcare data accumulating from patients and populations, and the advanced analytics can give those data meaning, hold the prospect of becoming an engine for the knowledge generation that's necessary to address the extensive unmet information needs of patients, clinicians, administrators, and healthcare policymakers. And furthermore, I went on to say that I felt that this was a historic moment in medicine. I realized this was about a decade ago, but I still believe this, that there's a remarkable opportunity to promote medicine as information science and strengthen the foundations of a learning health system. Defined by the IOM as designed to generate and apply the best evidence for the collaborative healthcare choices of each patient and provider to drive the processes of discovery as a natural outgrowth of patient care and to ensure innovation, quality, safety, and value in healthcare. But this idea of out of a natural outgrowth of taking care of patients, that we're going to be able to learn in real time, and that's going to feed back in to what we're going to be doing. So what do I want clinicians to think about is how is this revolution going to manifest itself, and how can we best take advantage of it? So, the analogy here is that we should, what's going on in industry. With every purchase on Amazon, with every search on Google, with every mile driven on Tesla, those systems get smarter. Now, they're your classic closed loop systems, because as you're clicking on Amazon, they know whether you've made a purchase. When you put in a search term in Google and you get a whole range of potential results of that search, they know what you click on. On Tesla, they can tell, what's going on with regard to the driving experience and share it among various different systems so that they can get smarter. But in medicine, we've traditionally not done this. And we've left on the table the entire experience. I mean, it accumulates within individuals, but with regard to being able to aggregate, organize, curate, and learn from, as a community, each other's experience with patients, as those of us who are clinicians, we have not done a good job. I mean, that's generally been a laborious process. Sometimes we publish case reports, then we publish studies, and we do trials, but all of this takes a lot of time, and it's not going in real time where we're able to do this. And there's also presumption in this era of AI that can also take on tedious tasks and make the workflows easier, that we can actually transform the way in which our human interactions occur. I'd written a piece with Hader Warwick and Rob Califf about the connection with the clinician relationship, AI with the patient-clinician relationship. And the idea with it, the digital transformation of healthcare has a potential to make healthcare more humane and personalized. It actually, if it works right, it should give us more time to make those human connections, and it should give us more capability, improve our performance, enable us to be able to create the profession that patients deserve, not one that's purely transactional, but rather increasingly relational. So I'm get back to this question: what is it that clinicians need to know about AI? So being asked to give this talk was a challenge to me, because it was, okay, what is it that should be conveyed? And I guess in a traditional format of a talk like this, then what I would do is transition into a laundry list of items that clinicians should know about, that we should be able to quiz them on afterwards, and to ensure that people are all up to a standard level, a common level of understanding of some of the basics. And there's some merit in that. And so I thought, I could tell people that there's a few things that clinicians should know about. They should know about types of AI. They should know about the benefits and limitations of AI in medicine. They should know about AI ethics. They should know about AI regulation. They should know about evidence-based practice as it relates to AI. They should know about integration into workflows with AI and implementation science factors, human factors also around the use of AI within medicine. By the way, each of these things we could take an entire lecture, entire day, entire course on. They're deep and broad, and there's a lot that people could know. Say, for example, what are the types of AI? Well, we could spend time talking about natural language processing or machine learning, computer vision as they apply to medicine, robotics, expert systems, neural nets, deep learning. We could talk about machine learning as a broader category of artificial intelligence that encompasses a whole range of techniques, and deep learning is a subfield that focuses on training artificial neural networks. From there, we could break down deep learning and talk a little bit about some of the other areas within that. But the question is, what is it that doctors really need to know? We could go on and traverse to AI ethics, as Carol indicated, a deeply important area as we get into AI. Sure, clinicians should understand the potential benefits of AI, but they need to be able to think about these or this in the benefits. Sorry, I got ahead of myself. In the benefits and limitations, we should be talking about the need for people to understand what aspirationally can be achieved. How much can this improve accuracy and efficiency in diagnosis and treatment planning? How can it help us with regard to pattern recognition, early detection of disease, signatures of disease before we're normally being able to capture them? Can it help us with personalized medicine? Can it reduce healthcare costs by creating efficiencies, helping us make better decisions? At the same time, can we appreciate that there can be a lack of transparency in decision-making, bias and fairness issues, privacy and security concerns, potential for incorrect or harmful? We can always make things worse, despite best intentions to make things better. So, clinicians should have this appreciation that it's neither an unadulterated good or bad. It's a potential tool that could enhance our performance, but if used incorrectly or configured in a way that somehow is providing us with information or guiding us in ways that are going to make things worse, could cause harm. And so we've got to be able to clinicians need to have an appreciation of that. I've gotten ahead of myself to say that, and maybe because I'm eager about talking about it, that clinicians need to know about AI ethics, familiar with ethical considerations surrounding AI, including issues related to patient privacy and confidentiality, data security, algorithmic fairness, and accountability. It starts with, are the data ethically sourced? Where did they come from? And to what extent do they represent what's really going on? And so there's, again, a very deep amount that we could talk about that clinicians should know about this. How about AI regulation? Should clinicians do have at least a general sense, if not an expertise, in drugs and devices? I mean, there's of course a very deep fields there, but they have some sense of what goes into what it takes for a drug to get approved or authorized, but how about in AI? I mean, these are considered often devices. There are devices that have AI in them, but actually even the algorithms fit under CDRH. They're considered as, like many devices are. And to what degree do physicians need to understand the role of the FDA, the importance of using validated and authorized AI algorithms in clinical practice, and what is it that goes through the FDA? What is it that doesn't go through the FDA? Once something has been through the FDA and continues to be updated in clinical practice, to what degree is the original determination actually relevant to what's going on today? I mean, clinicians are going to need to know about that. They're going to be needing to think about integration. The idea that there's AI or fancy-dancy algorithms that can do specialized functions doesn't mean very much unless it's going to be able to be integrated in clinical workflows. And clinicians are going to need to understand, how are they being integrated and how is it affecting what I'm seeing and what's going on and what's happening? In some institutions in this country, they're running A/B testing for a lot of different strategies for patient care. Clinicians may not even be aware of that underlying testing that's going on. It's going to be important for them to understand how the workflows are being affected, what kind of evaluations are being undertaken, and what the effects on their patients may be, and on influencing decisions. And then finally, I mean, we could talk a lot about how clinicians should probably be aware of, like, evidence-based clinical practice. I mean, where is the role for the evidence that's needed to help us understand how to optimize the use of AI in practice? We talk a lot about evidence-based approaches when we talk about other clinical strategies, but these interventions, again, if we're going to acknowledge that they have the potential for benefit or harm, then we need to understand how we're going to be evaluating, guiding their use, and then monitoring once these things are in practice. And how are doctors, nurses, pharmacists, PAs, how is everyone going to be able to interpret the kind of evidence that's going to be generated about this, that's going to help us understand the validity of these models, what role they can actually play, the value of the information, the trustworthiness of them? I mean, can we, starting from whether the data was appropriate to all the way to, is the output helpful? Is it free from bias? Is it fair? Does it have actual clinical utility? How about the explainability, interpretability, transparency of what's coming together. Is it just a black box that we're supposed to trust? Or are there ways in which we need to be able to evaluate what's being presented? There's issues, of course, also just about technically the security and privacy, and what does it mean for individual patients? And how is the design being handled in ways that might influence us in good or bad ways? There's the evidence itself, but I want to just take a moment also just to pause about the data, because the data also becomes quite a big deal, because you may go and look and say, I'm trying to understand what did they do here? But you may also want to understand, what was it based on? So, you know, this new world is highly dependent on the acquisition and refinement of data. It's what feeds the development of these algorithms, these tools, but also it's very important for the ultimate validation. How generalizable is it? How durable is it? Different sources, lack of standards, high degree of fragmentation. It all means that, acquisition aside, the distance from the raw data to an analytic data set can be quite large. And lots of things can occur throughout that process. That processing of the data, the organization, curation, harmonization, the way in which the data is handled becomes actually another important issue. And maybe physicians need to know it's more complicated than what they believe. When they see an article that comes up and says, we took EHR data, we took data from X, Y, and Z, you know, that's not case report form data. That's not a human abstracted data. Those are data streams. And in order to extract information from them, how was the data mapped? How accurately was it mapped? When it says this was X, can I trust that it was X? Because you wouldn't believe how often things are miscoded or poorly organized or difficult to ascertain. And that's why the FDA continues to say they're concerned about the quality and completeness of data that's being used in regulatory decision-making, because it's not so simple. So even when we see a paper, can be in a highfalutin journal, and they have one line, you know, data source, electronic health record, that tells you nothing about exactly how that data was handled and how the central variables were created. So there's lots of different ways that it could occur. And, you know, there's also this issue of, as an example of what I sometimes are calling mystery reagents. And I don't mean that to ding that, but there are these large scale data aggregators that are getting data that are leaking from healthcare systems through business associate agreements. So a healthcare system like Yale will have a contract with another company to do a service for Yale. That company will say, in order to do that service, I need access to your data, Yale, and I'm your partner. We have a business associate agreement. Yale shares all that data with that company. Now that company under HIPAA has the opportunity to strip it of identifiers and sell it, monetize it. And then so there are companies that are accumulating large amounts of data that are leaking from healthcare systems. You ask Yale, where'd your data go? They don't know. They don't know where it went. But they don't even know that it's been transacted this way. But the data ends up going in different places and forming these large data sets. Now, in some cases, there are also companies that actually make explicit agreements with the healthcare organizations. And this article is an example of that, Trinetics, where they actually have specific agreements with healthcare systems. But part of the agreement is Trinetics can't reveal who the organizations are, so where they're from or how exactly it was processed. So this was an article that came out in Lancet Psychiatry that didn't use AI, but I just use it as an example about neurologic and psychiatric risk trajectories after SARS-CoV-2 infection. Analysis of 2-year retrospective cohort of, you know, over 1 million people. But in the supplement, not in the paper, but if you look in the supplement, they say the network contains data that are provided by participating healthcare organizations who agreed to allow their data to be used so long as their name remains anonymous as a data source. So that means that people are starting to do analyses, develop algorithms. You ask them, where'd the data come from? No, they can't tell you. They can't tell you. And so maybe that's okay, but it starts to create, you know, issues about, well, where did it come from? How was it processed? What can we infer from where that data is and the quality of the data? And maybe somewhere that company, and I don't mean to pick on any particular company, but maybe they do have some white paper somewhere that explains a little more detail about how they process and organize it. But it becomes to be difficult in some cases to really track down all these issues about the data. The issue also is, as I've said, the data can be biased. And that's why another reason it's important to understand where it came from. We've seen this inconsequential AI in the justice system, but also in medicine, it's also been revealed. So if we're training on data generated from systems with systemic racism, then the outputs will reflect that system, and the predictions will reflect the biases that were embedded in the original generation or production, really, of the data, because it was the experience of a system that was already embedding certain beliefs and behaviors and issues within that could even amplify these biases if we don't begin to open our eyes and realize that they're there. Now, there's another thing here that is about, I'm just blanking the slide here for a second, that is about the just pure performance of the AI that's produced and the transparency in that performance. So I think clinicians should know that AI models don't always perform at high levels. You say the word AI, machine learning, maybe it helps you get a paper published if you're a clinician, if you're trying to, get out there and get some attention. But there's a lot of heterogeneity in this over time. So, a good example of this was this issue of sepsis. And I just to make sure that all of you were aware of this, of course, sepsis is a life-threatening condition. It's really important to recognize it early in the emergency department and to begin treatment rapidly. And so there's a premium on being able to help physicians to make that recognition. You would think physicians could be able to recognize it, but early signs, especially in a busy emergency department, could pass by people. So there's been an interest in trying to develop algorithms that could help improve performance. Well, Epic Systems, a very popular electronic health record, developed an algorithm that they embedded within the electronic health record in order to help clinicians, but it wasn't really clear what its performance level was until a group went on to do this. Some of you might have seen these headlines. A hospital algorithm designed to predict a deadly condition misses most cases. And this was the JAMA IM paper that came out. And what they did was they sort of carefully did an external validation study. And they found that the EPIC sepsis model had very poor discrimination and calibration in predicting the onset of sepsis. And that, for example, alerting at a score threshold that might have been used within an institution, that it only identified 7% of patients with sepsis who were missed by a clinician. So, the problem here, of course, is if a clinician missed it, they may just be relying then on what the output is to reinforce something that actually isn't true. And also, by the way, there was also issues just of general performance using other metrics. So we wrote a piece about this because this sepsis model was able to get into EPIC, but it didn't have regulatory oversight. And the question sort of is, well, what is the proper amount of regulatory oversight? What should be need to have approval? If clinical decision support algorithms are designed to be continuous learning models, how do we continue to update? I mean, these are lots of discussions that clinicians should know about. They shouldn't automatically believe that even if something's in their EHR, that it represents something that they should rely on. And so that's a problem. And then, like I said, with the regulatory issues, it's not always there. We published a piece about what are some of the metrics that should be transparently publicly reported from something that's expected to be used in clinical practice. We published this in Circulation, Quality, and Outcomes, performance metrics for comparative analysis of clinical risk prediction models employing machine learning, led by Chen-Shi Huang, and felt that this was important to not only capture the traditional things that you might see within an ordinary academic contribution that maybe used logistic regression or something, but as you start to begin to look at these models, talking about a wider range that we're capturing different dimensions of performance that might affect patient outcomes and would need to be important, but yet this has yet to be really adopted as into full practice. So let me get back to this question. So what do clinicians really need to know about this AI? So let's start in the beginning, types of AI. You can go deep into this. You could ask this question. Do clinicians really need to know about recurrent neural nets, for example, that they're a type of deep learning that can process sequences of data, such as time series or speech or text, and can recognize patterns and sequences? Should we be, having a lot of continuous medical education about this? Should we incorporate this into the medical schools? I mean, should they know about, convolutional neural nets as a type of deep learning model on the human brain? that also has multiple layers that can lead to prediction about, for example, an image. What is it that we should say is essential knowledge? So do they need to know about the RNNs or the CNNs or the generative adversarial networks? I mean, what is it that we need to do and really get a competence about? But let me ask you this also. I mean, I've had this question for a long time. I mean, what do they really need to know about genomics or biochemistry? I mean, what we defaulted to say everybody should know the Krebs cycle, but now ask a bunch of clinicians to draw out the Krebs cycle. They're active in clinical practice. They may be practicing very high levels of their profession, and I doubt that very many of them could do more than maybe recall the mnemonics that were associated with the Krebs cycle, but to really be able to understand it and talk about it with any great fluency, they can't. And so the question sort of is, as we get into a world of AI for clinicians, what is going to be that essential knowledge? What do they really need to know? And it sort of got me, and in this sort of last part or half of the talk, maybe a third or less of the talk, I really got me thinking, you could spend a lot of time and a lot of lectures trying to get clinicians up to speed on some very technical topics, or you could start thinking, well, what do those working with AI really need to know about clinicians? Because really, maybe it's about flipping that, because maybe it's more about the data scientists understanding the world that they're trying to assist in. And in that way, they should know that, hey, we're a hardy bunch. We're well-intentioned. It tends to be a smart group who's working hard to stay up in the field and deliver the very best care in partnership with their patients to achieve the best outcomes, but are very busy and don't really have time to start diverting attention into different directions or managing different new systems that they're not even confident are ultimately going to help with their patients. I mean, in general, clinicians don't want to know so much about how it works, but whether it works. And by the way, this isn't so different than a lot of things. I mean, there's a lot of people who don't know how an internal combustion engine works, or let alone an EV works, but they're pretty good drivers. There's lots of people who are winning Olympic medals as skiers, but they actually don't understand the physics of friction very well, but they know how to ski. And so, there's different ways where people would need to have different kinds of information to be able to do the function that they're in the best position to do. I mean, they want to know, does it work? And, you've seen this, or whether it doesn't work. I mean, these autonomous cars, you start seeing, I may not understand exactly what's going on in the program, but I can tell whether they're safe or whether we're hearing about crashes and whether or not they should be used. Importantly, I think clinicians sometimes understood by the data science community as being averse to technology or being averse to change. But I'm here to say clinicians are not Luddites. Well, not all of us anyway. And actually, I think, what's the evidence of that? Well, give us something that works. And guess what? We don't even need to know if it's AI. I mean, most clinicians, I think, are using smartphones. And that means that most clinicians are every day using AI, every day using it. And you know what? They adopted it really quickly. And you know what? They didn't have to go to any classes about it. They didn't have to have any special education. We didn't have major CME about how to be able to open your phone with facial recognition. And by the way, that many of them don't care how facial recognition works. You know what they care about? It works. It works. And this is kind of the mentality that we need to be able to take into thinking about what is it that people need to know and how do they need to know it. So, for example, when you look at this actually is based on probably millions of sensors and such an enormous amount of data feeding into very advanced prediction models that are highly sophisticated and producing output that is reasonably accurate about what's going to happen in the future. Now, my mother can look at this map and immediately understand really multiple dimensions about it. She can recognize the geographies and what it means, what the colors mean, and she's never taken one class on that. By the way, she uses an iPhone, never took one class on it, let alone clinicians. But my point is, this is highly sophisticated AI, and nobody had to be trained on it, and everybody uses it. I mean, here's another example. No one got trained on Waze or Google Maps. I mean, you just started using it. And also very clever use of color, very clever use, by the way, of data sharing in order to help augment and potentiate the means, the knowledge that the next person could use. The car in front of you is feeding in information that's benefiting you, and you're feeding in information that's benefiting the car that's behind you. And that's honestly would be the best possible thing in medicine. The patient who's a mile ahead of me is helping me in my patient journey. And I'm helping the person a mile behind me, because the way the data is being able to be shared confidentially, securely, I don't know who that car is. I don't know who that person is. I don't know anything about them. But essential information from their journey is informing my journey, and my journey is informing the journey of the person who's going to follow me in ways that protects privacy and security, but also is enormously helpful and is presented in ways that no one had to teach me about. I didn't even have to read instructions about. We're so intuitive that immediately became useful. And this is the way I think we need to be considering this. And what's happened in the airline industry? Well, yeah, it's more complicated, and they do have training about how to optimize their use, but they've got at their lots of essentially dashboards or displays and information that's coming at them. And there's been a lot of thought about human-centered design so that a pilot doesn't get overwhelmed. It actually ends up being useful. Their performance is heightened. The entire industry got safer, not just because of the instrumentation and the data science, but that was an important contributor to changing it in a group, in a profession where there was a large sort of maverick streak, this idea that rugged individualism and people could manage this, but if you're going to go down with the plane, then you have even a stronger vested interest in the success of the trip. People adopted this pretty rapidly. And by the way, in medicine, I mean, I don't want to suggest that AI is not being used every day in ways that are helping patient care. I mean, imaging is just a minor example of this, but I mean, almost every image you're seeing, but nobody's coming and telling you and saying, you really have to understand the underlying layers that are helping to do the image processing. We're saying, clinicians don't need to know any of this. They don't need to know any of it. All they need to know is what's in front of them, but they need to know whether it's trustworthy and whether they can use it and rely on it. And as more data comes up, and as we're pushing for a system that gets smarter and smarter with every interaction, then it really needs to be presented and provided in a way that people can use seamlessly. So let me just contrast this with what the real experiences of clinicians today. So, I can ask this question: what medical miracles can AI produce? Hey, let's really talk about the wonderful day ahead, but let's talk about what's happening now. And I can start with a conception of most physicians as they enter the profession. This is going to be an old painting, but I'm just talking about the intense focus on the patient and the connection to the patient. So, this is a patient, it's called The Doctor by Sir Luke Fildes. And, physician sitting by the bedside of a sick child, a masterpiece of Victorian art. It was completed in 1891, but it captures the compassion and dedication of the healthcare profession, and is a representation of the bond between patient and doctor. This is kind of even though that doctor was in a position where that they could do very little for the patient, it still remains kind of a centerpiece of the profession to think that we have these kind of connections. But what has technology done for us in terms of the adoption? Well, it's done this. I mean, basically, it's turned us away from our patients, and it's sucked the life out of a lot of people in the profession. It hasn't made workflows better, hasn't convinced anyone that outcomes are improved. In fact, many people are concerned it's getting worse. There was this very, I think, important piece that was written by Atul Gawande, Why Doctors Hate Their Computers. The title was strong but accurate. So, it's not that doctors are Luddites or clinicians are Luddites and are averse to technology, but it's the way it's presented to them. He said, I think with a lot of feeling, I've come to feel that a system that promised to increase my mastery over my work has instead increased my work's mastery over me. So, we have to think what's the experience of this? And then we look in other areas, and we just haven't been provided the tools that would even make us feel that we're using modern technology. So, in 1819, Linnaeus invents this auscultation. Well, I don't say invents it then, but I mean, he has a classic treatise where he's talking about auscultation. And before that, he's sort of developing this where he can, use a tube to listen to the chest. But the truth is, what we're using largely today isn't that much different. And again, it's like, we're still teaching people to recognize patterns, recognize S1, S2, murmurs, gallops, instead of being able to put a sensor on the chest, maybe in 2 or 3 different locations, and be able to even collect acoustic information that's beyond our hearing range. And then not just tell us it's S1, S2, but come out with probabilities. This has 80% probability of severe mitral regurgitation, even before using anything like ultrasound. I mean, for some reason, we're progressing so slowly. By the way, anyone who evaluates the auscultation abilities of physicians in this country sees repetitively that maybe there are 10 people in the country who are any good at using the stethoscope. The rest of us are using it for a symbol of our profession. But largely, every standardized test of the abilities of people, auscultation in this era is horribly is horrible. Electrocardiogram, again, pattern recognition by human brain. Human brain's not even so well configured for pattern recognition at the level of detail that's necessary in patient care. And we're still teaching people about descriptively what are they seeing morphologically, and they're less able to make those connections into its implications. Meanwhile, at our place, Rohan Kara is showing the power of being able to use AI applied to these sort of signals and provide interpretive information, actionable insights that can be used clinically and in everyday practice easily and seamlessly. Again, this difference between technology slow, making our life painful, and then we seem to be anchored in an era where we're still using, practicing much like the 1950s or before in a lot of different areas. This is a particular nit for me, is that our predictive analytics in healthcare that you will be asked on the boards about is really basically what is the risk of someone with atrial fibrillation of having a stroke? And you've got these very simple congestive heart failure, hypertension, sex, age. You give 1 point for, these different categories or 2 points, you add them up. And it's like, and what we're taught is if your score is greater than 2, maybe people should receive anticoagulation as protection. That is so not precise. It's not so beneficial. We need to be thinking about more precise and better information. By the way, the web has got so you can enter this and have it do simple addition for you. I mean, it's crazy. This is where we're anchored in medicine. You have remote monitoring where we're in situations where it just blows up. The data comes in, it's overwhelming. It's not organized. It's not providing actionable insights. So we need to move from this conception, and I'm just getting here to the end, we worked out very well this idea of bench to bedside, working in a lab and being able to create innovations and discoveries and moving them all the way with an evidence base that would help you understand and your patients to understand how they might be useful. We need to start talking about calculation to clinic or some such type of conception where what we're doing is bringing together these and generating the evidence that is going to help us be able to move forward. I like this quote by Daphne Kohler, machine learning is capable of making sense of immense amount of high content biological data, most of which is two-dimensional for humans to interpret. Well, not all medical data is high dimensional, but there is an immense amount of it. And there's no question in my mind that AI can be used in ways that can help clarify, organize, and elevate the way in which the profession operates. But it can't be the kind of technology that we've seen so far. It has to be a new era of the way in which both data collection through advanced sensors. And why isn't every patient in the hospital having sensors that are telling us what's going on at both their activity, their sleep, in addition to heart rate variability? I mean, why is telemetry reserved for only some of the patients? I mean, how can we put that data to work so that we can be able to more efficiently care for larger numbers of patients and be able to attend to their needs? This is the questions. So what clinicians need are solutions. I'm not sure they need more education. What they need are tools that improve what they, in partnerships with their patients, can achieve. What do they need to know? I think they need to see the output. They don't need to know how it works. I can't have a talk today without at least mentioning ChatGPT. I'm blown away by what it achieves. I get it, generative AI, but I'm not really sure how they pulled this off. It's unlike anything I've ever seen before. I think it's a remarkable transformative event within AI and its application. I think there are a million ways it potentially could be used in medicine, both for good, but it also could have potential for harm. Again, we need to be thinking, how are we going to accelerate our ability to leverage the breakthroughs that are occurring on the data science side to be able to ensure that patients are net benefited, and ultimately that the future is better than the past. All know what makes good AI. It feels like magic. You don't have to understand it. When I put up my phone and it recognizes my face, it feels like magic. You need to know it does what it's supposed to do. In medicine, we'll need to know it's safe and effective, not biased, that the data were ethically sourced. We need to know AI can go wrong. But do clinicians need to know about the CNNs, RNNs, generative AI? I don't know. I'm not sure. I don't think so, probably. They need to know how to use the tools. They need to know whether the tools can be trusted. They need the magic where and when it's needed to produce information that can make a consequential difference for patients. And then the trust and confidence that that magic is doing the right thing. When I'm using my phone, I can tell it works. When I hear the weather forecast, I get a chance to see if it works. In medicine, we have to build in these closed loops to know whether or not it's doing what we think they're doing. We need to build in better real-time methods. That'll make the algorithms better over time. And we need to determine what's good enough performance, because perfect performance will always be beyond our grasp. In our current system, we're not quite achieving this. We need to be able to get to a point where we can be high tech and high touch. Reserve the touch for where and when it's absolutely needed, but don't fear being able to bring in the technology to help our performance elevate, because we desperately need it. So, my last penultimate slide is just about all of this needs to be done in the context of maintaining the core of what's important in medicine and in health and healthcare, which is a concern for individuals, a commitment, a devotion towards ensuring that we're doing the best by them. We're helping inform their choices. We're not telling them what to do. We're working with them on solutions that best fit what their lives are and what their preferences and goals are. But we're being able to use every single part of what is in our ecosystem and what our expanding computational and analytic breakthroughs are allowing to ensure that people are able to benefit from that, and that benefit is broad-based in promoting better equity within our healthcare system as well. It's not sequestered for the benefit of the few, but we make sure that it is put out for the large numbers. So AI for clinicians need to know about what's possible, need to know about benefits and harms, but mostly need to know about how do we continue to push for demand for the kind of tools that are needed within practice, where actually you don't need to be an AI expert, but you're able to use AI every day to improve the outcomes of your patients and to work more closely with them to achieve their goals. Thank you.
Wow. Thank you so much, Dr. Krumholz. That was fantastic. It's really clear listening to you talk that you've thought about these issues longer and more thoroughly than most clinicians, and I'm so grateful for you joining us today. I have a first quick question before we open it up. I have noticed that we don't treat AI like we treat any other new technology or new tool in medicine. We don't demand data to show the benefit. So for instance, do we need randomized controlled trials to show that an AI-informed algorithm improves outcomes compared to a clinician experience-informed practice? Do we need that?
Yeah, I think that in parallel with this revolution in clinical care and our aspiration to improve clinical outcomes, we also need to be reforming our research infrastructure. And we need to be able to figure out how we can be learning faster, cheaper, and in real time. That was my whole point about this learning healthcare system, because I think we would have the potential to do great harm to the entire potential of AI if we encumber it with the kind of traditional approaches to research and evidence generation. We need to be able to create evidence pipelines. So, we're going to need to have a reasonable expectation that something is going to produce a benefit, but we're going to be able to have the the data streams and analytics prepared so that in real time we can be learning whether or not we're achieving what we might expect to have occurred as a result of the work we've done. Not have to build up a large, slow, even expensive set of studies, but ones that can travel in parallel. And I think we could be also using AI and a lot of data science in order to be able to produce evaluative algorithms of those interventions that we're making. But make no mistake, we need to be able to recognize there's potential for benefit and harm. And anytime you have that in medicine, anytime you're changing things, we need to be able to have very strong efforts to evaluate that are built in right beside it. But we want to make sure it's just not going to slow everything down so it takes decades to learn. By the way, these are fast-moving adaptive algorithms. So they really need to be able to evaluate as they iterate over time.
I got to tell you, I my concern is that we'll miss things, because I like what you say. We have to keep evaluating the data and see if we're getting what we expect. But again, the biases and the preconceptions that we built into our model will also inform what we expect to see. And I wonder if there are sometimes we are going to need a randomized control trial.
Oh, and I didn't mean to preclude it, just to say, I think we're also going to need to have something that's going on every day. But we may, if we're especially making a big change that potentially could have great benefits or harms, we're going to need to study those. You can still fit. Lior Horowitz is doing a great job, I think, at NYU, trying to figure out how to embed within their systems this A/B testing. And I didn't mean to suggest that was bad, only that it needs to be transparent. But I think Lior is trying to build in a learning healthcare system the capacity to do that randomization in ways that can be tested and is highly responsible and produce knowledge pipelines. We need to get many consortium of institutions working together to do that.
Totally agree. All right, we have a lot of questions coming in. First question from Jay Margin. Since decisions about purchase and deployment of AI will be made by insurers and health systems, not clinicians, the main factors that will be considered will be cost and performance and not patient and clinician experience. Is there a way that we'll be able to change that? That's great.
Oh, I think that's such a good question. And I'm so sorry that the beginning of that question seems to be a surrender to a reality that the clinicians will be somehow excluded from this process. In the end, really, it is clinician and their patients who are going to be the users of these outputs. And, you know, we have to have a strong voice about the key importance of including clinicians at every stage of decision-making around these, and evaluation and iteration. And ultimately, this will not succeed. I've seen a lot of cases where, you know, new packages or interventions or programs have been started. And it's, you know, it's the same kind of thing with community-based research. You want to work with communities, you have to include the communities. This kind of work, actually, the clinicians are part of the community. And honestly, if you exclude them, you're predestining almost the entire effort to fail, because, you know, there's no system that clinicians won't be able to figure out workarounds if they don't really want to use it. They don't buy into the idea this is potentiating their performance. And so it's essential that we speak with a clear voice. By the way, I also think that the patient voice needs to be in there as well as we start to implement these systems, so that there's conversation, dialogue. But at every institution, we need to be clear that it's like this: without including clinicians, the consequence will be a lot of wasted effort and resources. That's, you know, if people don't care about that, it's the right thing to do. Actually, I think the efforts will be undermined unless clinicians are involved from the very beginning.
Great. Thank you. Okay, another good question from Nicole Shroka. Oh, someone just answered that. Oh, here we go. Appreciate your thought, leadership, and passion today. Can you say more about the common types of bias you see from medicine-based algorithms?
Yeah, I mean, imagine if you've got a situation where you're trying to determine whether you want to trigger into palliative care, and you've got a model that's leveraging off, there are certain groups who are not getting the same high quality care, or whose outcomes are worse for reasons that are separate from their medical condition, but have to do with the social context of their lives, systemic racism, a whole range of different other issues. And you're basically could be predicting something which accurately predicts it, but it doesn't have to be that way. And so it's somehow triggering you to say, well, these people are going to have a poor prognosis, but it may be because of factors like that we could actually modify, better support or access to medications or things like that, that you shouldn't just default to that. There was I think a very nice piece that Ziad Obermeyer published that talked about at the Brigham, they were trying to figure out where to produce resources, who were high cost utilizers. And it turned out that those who had better insurance were higher utilizers of resources. And so they were putting disease management to sort of focus on those individuals. When actually, if you just went on health basis, some of those people who had lower healthcare utilization actually had worse health and outcomes. And it was because of the way that it was structured. So, you know, again, these kind of biases could lead you to conclusions like, oh no, that's the group that needs our help the most. But if you leveraged it based on healthcare utilization, you would have been missing the point that some people have barriers to that needed healthcare utilization and don't look like they need as much intervention when in fact they needed more. So, you know, these are the kind of biases that can creep in.
I completely agree. One of the things I worry about the most is all of our algorithms are using data sets, and the data sets have biases embedded in them. Certain people get their genetics testing, you know, European white males more commonly, and certain data we just never see. And it's the data we never see that may be even more important than the data we see a lot. So my biggest concern is the data we never see.
So we need to work on that inclusivity to be sure that these are being based and validate based on not just the places where they were derived, but also to ensure that they're generalizably valid in larger scale populations.
Great. Lots of questions. Okay. What is the best way to leverage high frequency waveform data secondary to patient care with, for example, outcomes condition with similar data sets curated by other healthcare centers? We have excellent physiologic waveform data for variability analysis, but want to find other comparable health center with similar cardiac catheterization lab data. How do we find a collective data clearinghouse pointing us to others for federated alerting?
Oh my God, that's such a good role for Bridge to AI, you know, to be able to do like a dating service where it's like, who's got data that they want to bring together and who wants to try to do this. And also it's nice to have some standards around how to harmonize the data, but also how to maintain security. There's a lot of work, of course, on federated learning models now and how we can do this, but we have to really create the standards. I think there's a ton of information in these waveforms that we're leaving on the table and that could be useful to inform both prognosis and treatment response and also just, you know, general monitoring of disease activity. But yeah, I love that. But how about Bridge to AI? That'd be a great place for that to happen.
That's a great point, Pepe. Let's think about that.
I completely agree. So if you could send us your contact information, I'll make sure the right group of people will get in contact with you. I think important come to my mind will be the administrative core in charge of the entire coordination and management of Bridge to AI activities. And I make sure Lucilla gets your contact information.
Okay, great. Really great questions. I want to keep going. I understand some people have to break off, but they were really great questions. This question starts with a quote: "Culture eats strategy for breakfast." AI adoption is not about technology. Many clinicians are afraid about losing their identity as clinicians to make a diagnosis, pattern recognition for medical practice. Any thoughts about how to manage the change management, especially for senior experienced clinicians? So they're maybe just afraid of losing their.
No, I think it's a really good question. This is a point I was trying to make. By the way, I agree with this completely. And a lot of adoption issues are really about culture, as our quality and so forth. But one of the things I was sort of coming to was, if you come to them and say, here's a new AI package that you should try, that's one thing, right? I think that's going to meet a lot of resistance. You know, people may even feel loss of autonomy and disrespected about their own abilities. If you embed tools that are natural and intuitive to use, that make me a better physician, make me more effective, and actually I can get even feedback about how my patients are doing better as a result of these tools, then who's going to want to be left behind? I mean, if it's a competitive advantage, personally, to be able to adopt new ways of doing things, I think people will be avid for it. And that's why I was making this big point about the phone and the weather and Waze. Like, you know, nobody sat there and said, God darn it, I'm a good driver. I don't need this Waze thing. People are like, this thing's useful. Like, it actually makes me more effective and a more effective driver. I mean, I can make better choices. I'm more informed. Instead of saying like, get away from me. I've been driving since I was 16 years old. I don't need that. You know, it's like, it's up to us to build the tools in a way that seemingly will and meaningfully, tangibly will help people to do better. I believe rather than lecturing them on culture or trying to figure out how to convince them. If you come in with something, here's a black box, it's going to tell you what to do, just follow these directions. Yeah, that's going to be resist, no question.
Great. Okay, next question. Thank you so much for your talk. Can you comment on strategies we should use to integrate innovative AI tools into our various EHRs, Epic, CPRS, Cerner? As you know, most EHR systems are resistant to information sharing for a variety of reasons.
I always say this, like, so who's the boss? I mean, look, the patient's the boss, and we got to figure out like what's in their best interest and stand up and demand that whether it's data sharing or integration of new things. I mean, the monopolies that exist within the HR groups can't create a stranglehold because their business models don't want to permit the kind of things that are in the best interest of patients. It's up to us to speak loudly and clearly that it's important around the patient side of this. With regard to the actual tools themselves, I want to say it's important for us to find those points where could we be helped? Where is it that we think that there are areas that I see sometimes within the EHR, there are decision supports that are just dumped on us. And we got to click through them. They're obtrusive. They slow us down. They don't make us feel like we're being empowered or assisted, but they make us feel like we're stupid and we don't recognize things that are in front of us. And so we've got to be able to work through this both in terms of how they are, this sort of human-centered design, and as well as this issue of if any impediment is being placed in front of us by the EHR companies that in any ways conspiring against the best interest of the patients, we got to speak loudly about that because it's really important.
Great. Okay, next question. I'm also surprised by our eagerness to regulate AI. We seem to be content within the notion that humans make mistakes and only punish humans when mistakes they make are harmful to others. However, has anyone even tried assessing the dangers of misrepresentations produced by AI compared to misrepresentations and mistakes made by clinicians? So comparing AI-induced mistakes to human-induced mistakes.
Yeah, I think it's important not to set up humans versus AI, but to figure out, what can AI do to enhance the performance of physicians. It's not really, and people talk about not so much artificial intelligence in this way, but sort of augmented intelligence. Like, how do you augment the user's intelligence in a way, by the use of these? But I think it's a really fair and important point, and this is what was trying to say repetitively too, which is all of these have potential for harm, just like almost any intervention we make in medicine. And so it really is incumbent on us to build in the systems that evaluate, where being presented certain information. It could be misinformation, it could be mistakes or errors, biased information, or it could just be that the way that process works slows us down or distracts us from something else and we make another error. I mean, there's a whole wide range of ways in which these can undermine good practice. So anyway, I think if your point is that we need to be able to look hard at this, not accept this, as like I said, as an unadulterated good, but as a potential good that needs to be optimized in a certain way and evaluated consistently and continuously, then we will have achieved what we need to. But yeah, we can't just accept it because it shows up in the EHR. My question is, what's the performance metrics on this? Where are the specs on this? How can I trust it? And we need to be able to have that in AI, no question.
Okay, and the next question speaks to trustworthiness as well. For the question of trustworthiness, aren't we still ready to trust a human authority with proper amount of charisma without questioning their potential subjective bias? Yet we're so obsessed with the bias AI might produce and penalizing it, even if it is only 5% wrong.
Well, I do like this one too. Maybe it relates to the prior question as well, but in another way, which is, we can't expect the AI to be perfect and look at it really should be against the standard current practice. And humans have failings. They have failings in pattern recognition. They have lots of biases, representative heuristics, based on what I've seen recently, makes me think about something. If we really have good AI, it's almost like an independent extra opinion on my shoulder that's helping me to make sure I'm not overlooking something and maybe introducing new ideas around patterns that I can't do. As we bring in sensors that are beyond our sensory capability, I think with regard to imaging or ECGs, other things, there's information there that we haven't perceived in the past, connections and relationships to outcomes. So yeah, I think our benchmark is human performance, which is flawed. It still can be, good, we're doing our best, but the question is, how can we work synergistically with this new potential that actually creates the level of performance that we've never achieved before. But yeah, I mean, that's why I was saying we can't expect the AI part to be perfect. We really need to know, can it improve upon the current standard of care?
I agree with you. My concern is that if you have one clinician who's biased, he has the ability to impact one patient at a time. If we have an AI algorithm that's biased, it will magnify the bias over time, and we can impact thousands and millions of patients. So that's
and I endorse that. And that's why, if you noticed in my talk, I said it can amplify biases. And that's a real danger. That's real danger.
okay. What if it's not AI in medicine, but rather building the tool right? If you're not looking for the right needle in the haystack, an AI algorithm won't help you find it. It's a good question.
Yeah, I would say the biggest flaw in a lot of AI that I see in medicine is that they haven't asked the right question, or they're not really deeply understanding the value of the information that's being produced. So that, I had actually a slide, I forgot, my talk was already too long, but talking about this concept of value of information. And really, ultimately, we need to be able to say, in a way, your willingness to pay, like, how valuable is that output? What decision does it affect? Why does it make things different as a result of it? What is actionable about it? Because if we're just producing knowledge, but actually there's no actionability to it, then it may be of some interest, but not really very valuable and won't be incorporated into practice. So I think it's key critical importance at the outset to be saying what problem are we trying to tackle, and what information would actually make it better.
Right. All right. Next question. Patients are different from each other: lifestyle, diet, geography, genetics, etc. Most are not measured or available. How can AI model individual differences for clinical use?
I think that you'll see over the next decade our ability to stream in more data. In the same way in the omics side, we're now talking about not just genomics, but proteomics, metabolomics. I mean, lots of different measures. I think on the more phenotypic side, on the patient and behaviors and social context, you're going to see all of this start to stream in and help us understand how they're contributing to risk and response, and how we can tailor for individual patients and complement the many omics data. So there will be more streams that are coming in. But even today, with what we've got, we have trouble organizing even that amount of data as humans. And I think that there's a lot of ways in which the AI can be a complement to what we're seeing. Now, as the clinician, we hopefully are seeing a broader holistic picture, but there still can be better contribution to that picture if the data is organized well from what's, for example, in the medical chart. And try doing a medical chart review these days. I mean, it's really hard to pull it all together in any sort of holistic way. I believe that AI is going to have that capacity to a greater extent, but or even like what I'm talking about with Rohan. So you see ECG, if we can improve the not information content that we can pull from even that 12-lead ECG, it will feed into everything else we know too. So we're improving the fidelity and value of information in various streams. Ultimately, we'll be able to integrate and organize that in more holistic ways.
Great, thanks. We have one final question, and I love this question, and I can't wait to hear Harlan's answer. Patient data is the most valuable resource the healthcare community has to train the AI system. AI will become smarter via our knowledge and experience encoded in the patient data. Do you think that AI will gradually replace clinicians in the long run?
I hope it will replace many of our functions that are tedious, repetitive, or that we actually aren't highly configured to do as well as AI might do it. Right. So if I say that if Rohan's being able to pull out information and content from an ECG that my eyes don't even detect, or I would never be able to do, like, I want that information. But there will, I don't believe, ever be a true replacement for sitting down next to someone, being devoted to them, dedicated to their best interests, and trying to serve as a guide that integrates knowledge across a broad spectrum and is able to connect to them in ways that is meaningful. And I believe it's not about putting us out of a job. It's about helping us to do better. It's the same way. Do we still have pilots in the planes? Yeah, we do. It's like, I'm not ready to go could the autopilot take us some of the way? Sure.
Yeah.
But I think we haven't gotten to the point yet, and I doubt we ever will, where it's really going to be that we don't need that human to human interaction in the kind of special computer you got up in your head. But this computer has some limitations. And the question is, can these new methods actually help us to do a lot better than we might be able to do otherwise?
I agree with you. And my favorite quote is, AI will never replace physicians, but physicians who use AI will replace physicians who don't use it.
That's great. That's great.
Dr. Krumholz, I cannot thank you enough for this really, really important talk. I learned so much, and I thought about so many new things, and I have so many new questions to ask you in the future. But thank you so much for sharing your wisdom and knowledge with us. And for everyone who joined us, thank you so much for joining us. We have a website that we will archive all of our skills and workforce development talks, including this one. So keep a lookout for that. And join us next week for Alex, what's the talk next week?
The talk next week is in Fundamentals in AI and Machine Learning by Dr. Jessica Lee.
Excellent. Yes. Thank you so much. Thank you all for joining.
Thank you so much. Great pleasure to be here. Thank you.
Thank you, Dr. Krumholz. Thank you, Carol, Dr. Watson. See you next week.
Dr. Krumholz, you never disappoint.
Okay. Okay.
No, seriously, that was fantastic. I mean, all those questions and all those thoughts, like you've thought about this more than anyone else, and I really appreciate that.
Oh, so much
The
fun.
more I think about it, the more palpitations I get, and the more insomnia I get. So these things keep me awake at night. So.
Well, it's up to us to figure out ways to make it work.
Yep. Again, thank you again.
you.
And,
Appreciate
thank you
it. Okay. Bye-bye.